Yeah, good morning, one and all. Today we will see Unit 3, Dynamic Programming and Greedy Approach. The first topic is Basics of Dynamic Programming. First we will see the definition for the dynamic programming. Dynamic programming is a method used in mathematics and computer science to solve complex problems by breaking them down into simpler sub-solution. So the dynamic programming is very simple technique. We are breaking down the bigger problem into smaller, simpler sub-problems to solve your complex problems. By solving each sub-problem once and storing the result, and it avoids the redundant computation, leading to more efficient solution for wide range of problems. Now we see how does dynamic programming works. Divide the main problem into smaller independent sub-problems, first step. Second step is solve each sub-problem and store the solution in a table or an array. Then third step is used to store the solution to build up the solution to the main problem. Then final one is by storing the solution, dynamic programming ensures that each sub-problem is solved only once, reducing the computational time. So these are the various steps involved in dynamic programming. Then example for dynamic programming. Example 1, find the Fibonacci sequence. Fibonacci sequence, 0, 1, 1, 2, 3, 5, 8. So it is a addition of previous two numbers. So brute force approach. Now use the brute force approach to find the Fibonacci series. Simply add n minus 1th item and the n minus 2th item to find the Fibonacci number. So this is the way you have to find the next number. That is what the Fibonacci series using dynamic programming. So see the diagram here. You are having the Fibonacci tree. Different nodes are different sub-problems. So using the sub-problem, you can find the main solution for the main problem. Okay. So F1, F1, F0 and F1. With the help of this, you can find the F2. Then F2 and F1 you can find the F3. F1 and F0 you can find the F2. Likewise it goes. So dynamic programming, it is a very simple method. You have to breaking down into bigger problem into smaller sub problems, and you have to find the solution for each sub problem to find the solution for the main problem. So approaches for dynamic programming, there are two approaches: top-down approach and bottom-up approach. What is top-down approach? In the top-down approach, it is also known as a memoization. We start the final solution and recursively breaking it to smaller sub-problem. To avoid redundant calculation, we store the result. Okay, let's break down the top-down approach. Starts with final solution, recursively breaking down into smaller solution. Store the solutions to the sub-problem into the table to avoid the redundancy. Suitable when the number of sub-problems is large and many of them are reused. Now, second approach, bottom-up approach. Again, in bottom-up approach is known as a tabulation method. We start with smallest sub-problem and gradually build up the solution to the final solution. We store the result in the result of sub-problem in a table to avoid the redundant calculation. So see here, first step is start with the smallest sub-problem, gradually build up the final solution. Second step is fill a table with the solution to the sub-problems in a bottom-up manner. Then suitable when that number of sub-problems is small and the optimal solution can be directly computed from the solution to the smaller sub-problem. So this is bottom-up approach. Then what are the common algorithms that use dynamic programming? Yes, longest common subsequence. This is to find the longest common subsequence between two strings. So here we use dynamic programming. And the shortest path in a graph. To find the shortest path between two nodes, you use dynamic programming. Then knapsack problem, determine the maximum value of item that can be placed in a knapsack. We use dynamic programming. Then matrix chain multiplication, which is used to optimize the order of matrix multiplication to minimize the number of operations. So here we use dynamic programming. Then Fibonacci series calculates the nth Fibonacci series. So we have seen just now how to calculate the Fibonacci series using dynamic programming. So these are the various examples or applications we can use dynamic programming. Then what are the advantages of dynamic programming? Yes, dynamic programming has wide range of advantages. First one is avoid recomputing the same problem multiple times. When you ensure the optimal solution, then breaking down the complex solution into smaller and manageable subproblems. Then what are the applications of dynamic programming? So dynamic programming has a wide range of application. One is optimization technique like knapsack problem, shortest path, maximum subarray problem. You can use dynamic programming. Next one is second area is computer science, longest subsequence, edit distance, string matching problem. Here you can use dynamic programming. Then operational research, inventory management, scheduling, resource allocation, task scheduling. Here you can use the dynamic programming. These are the various applications. That's all about basics of dynamic programming. Just recall the thing. So definition, what is the definition for dynamic programming? Yes, dynamic programming is a method used to find the solution for the bigger problem. So in order to find the solution to the bigger problem, you are breaking down into the simpler sub problems. Then you are solving each sub problem only once and storing the result in a table or any array in order to avoid the redundancy. So to reduce the computation, you can store the result. Then how does dynamic programming works? You know all the steps. Step 1, divide the subproblem. Step 2, solve each subproblem. Step 3, use to store the solution. Then step 4, store the solution solved once and reduce the computational time, and redundancy also reduced. So we have seen example Fibonacci series. And what are the approaches? Top down approach and bottom up approach. These two approaches are in dynamic programming. Then common algorithms that use dynamic programming: longest subsequence, shortest path algorithm, knapsack algorithm, matrix chain multiplication, Fibonacci. These are the common algorithms. Then advantages: it avoids the recomputation of subproblem, it ensures the optimal solution, then breaking the complex problem into smaller and manageable subproblems. Application: optimization, computer science and operational research. These areas we can apply dynamic programming. So that's all about basics of dynamic programming. We'll see one more we go deeper into the dynamic programming in next classes. We'll see some examples for dynamic programming. Thank you one and all.